Thanks everyone for joining us. My name is Daniel Bowie. I work on the immersive computing team at HP, and I look after Breath developers. Let me start by thanking everyone for joining us today. Today's webinar, we're going to be previewing a couple of cool developer technologies that we've built for you for Sprout. A couple of my teammates are going to give you demos and great detail of that. Before we do, though, I want to provide a bit of what Sprout is for those who may not have had a chance to use Sprout before. Once I do that, then we will take a look at a Unity plugin that we've built for you and techniques for unlocking Sprout's RealSense camera. And I've got my teammates here who are going to give you the deep dives for that. I'd ask everyone to hold Q&A till the end. Please go ahead and type your questions in as they occur, but we will cover all of them at the end of the presentation. Again, before we get into the cool stuff, let me give you kind of an overview of Sprout. So if you haven't had a chance to use a Sprout before, I want everyone to kind of get a sense of what kind of cool technology we're talking about. Sprout is the first in HP's roadmap of immersive computing machines. On the surface, it's a high-spec Windows 10 machine. It comes with a 23-inch full HD touchscreen. It's powered by an Intel i7, and it ships with 8 gigabytes standard, and I believe it's a 1 terabyte of storage. And of course, it's got a fairly high-spec video processor as well. Similar to, at least on the surface, most high-spec HP all-in-one. But to amend those capabilities, Sprout also includes these two sort of groundbreaking new technologies. One of them is the projected second screen. This sort of looks like a mouse pad on steroids, but really it's a capacitive touch mat, and it's 20-point capacitive touch, which means that you can have 4 hands manipulating objects on the screen at the same time. It's flexible, removable. It has sort of a magnetic buckle, a clasp that ties it to the rest of the all-in-one. And again, it's a 20-inch surface. That touch mat, when combined with the illuminator, actually creates a second projected horizontal screen. The illuminator includes a few different sensors and cameras. The first is a high-definition 14.6 megapixel camera. The second is Intel's RealSense 3D camera or sensor, which we'll be talking about later today. There's a desk lamp there, and there's also a HP's digital light projector, which projects up into the mirror on the illuminator and back down onto the screen as we discussed. The whole combination of this technology allows us to blend the digital and physical worlds in a really amazing way. You almost have to sort of see it to believe it. But essentially what Sprout does is it allows you to capture anything that is in the physical world, bring it into the digital world, and annotate it almost as you would annotate a digital document. You can annotate a physical or a physical object or a digital representation of that object. Artists love it. Kids love it. Anyone who is involved in any kind of a graphical work loves it because it's immediately a new intuitive way of working with physical objects. Another really cool thing is the types of application ideas that we've been seeing when we expose Sprout, or when we expose developers and idea people to Sprout. We've had just a breadth of ideas of all types of new ways to use these sensors. It really does kind of change the usage paradigm and makes computing more immersive, which is our goal as the immersive computing team. Recently, we rolled out HP's 3D capture stage. So Sprout has always had a 3D snapshot capability, and it allows you to take, using the digital high-definition camera and the RealSense camera, allows you to sort of grab 3D objects like on this slide. But with the 3D capture stage, we've made it very, very simple to take not just sort of 3D snapshots, but full 3D captures and create a full 3D 360-degree model. The 3D capture stage is one of those things, again, you kind of have to see to believe and really understand, but we can put an object on the stage, take it through a capture cycle in a matter of minutes and turn that into a fully manipulable model. We have software that will do some of the print repair and make that model ready for 3D printing. So we're really excited about the 3D aspects of it, and it's one of the core features of our Sprout platform. Speaking of Sprout platform, let me tell you a bit about how the platform works and what's in the SDK before I turn you over to the real experts who are going to give you the deep info that you're really here for. So we've built Sprout as again, a high-spec Windows machine, which means that the primary framework is C++ or C#.NET development. We've also recently announced support for JavaScript. And because it's a Windows machine, it's easy to develop using Visual Studio or Qt. And we've actually enabled use of the free Community Edition so that you don't have to make the full Visual Studio investment. When you download the SDK, you'll get access to our camera APIs that allow you to capture objects. We also have text extraction and object tracking APIs. And of course, we also have the ability to interact with the flexible touch mat. Remember, that's a 20-point capacitive touchscreen, and so it will allow you to capture 20 points of input simultaneously. You can get more information about the developer platform and everything that you need to know about Sprout at sprout.hp.com/developer. You can find the SDK there where you'll find all of our platform runtimes and bindings. And what's really cool is that when you download the SDK, you'll actually be downloading the full Sprout platform, which you can install on any machine and then develop against it. Obviously, you won't have access to the actual hardware, but we have dummy support for dummy APIs or dummy data for the hardware. We have a full set of documentation as part of the SDK and sample apps for C++, C#, and JavaScript. And of course, as a developer, on the developer forum, you'll find our Q&A forum, our guidelines, our design guidelines, sample apps, all the good stuff that you need to get started with Sprout development. Now, the two technologies that we're going to be showing off today are previews. They are coming soon, and they will soon be part of the developer website. We will be messaging everyone who attends the webinar when those two tools are available on the website. We're thinking this is about a 2-week, maybe 3-week time frame, and at that point we'll have both the Unity plugin that we're going to show you and the tools to unlock the RealSense camera available at sprout.hp.com/developer. So with that in mind, let me introduce Sohaib, who is going to walk you through the new plugin that we've created that gives support for using Sprout from within Unity. Sohaib?
Thanks, Dan. Hi guys, my name is Sohaib Ajmal and I'm a third-party developer support engineer for Sprout. And today I'm going to be introducing Unity plugin for Sprout and giving you a demo how to create apps for Sprout inside Unity. So let's start. So through the Unity plugin, you would be able to create apps for Sprout inside Unity. The basic functionality that you would be getting through the Unity plugin is the ability to make use of the dual screen touch and viewing capabilities for your Sprout inside Unity, and as well as the customized capture functionality specific for Unity, making it very convenient to perform capture easily inside Unity and get the objects that I'll be showing you in a while. The plugin supports C# for now, and the minimum requirements in order to develop for Sprout is the Sprout platform version 1.2 onwards and the Unity 5.0 onward. The plugin support development on non-Sprout systems, as you can add, as Dan mentioned, that you could develop on non-Sprout system as well. Similarly, for Unity apps, you could also develop on non-Sprout systems. So it's the time for demo. I'm going to switch to Unity. As you could see on my screen, so before that, let me show you how the structure of the screen. The main maximize screen is the Sprout main screen where you see the game area, which and on the bottom of that of my screen you see two small screens. They are the same view of the mat area of the Sprout. Now you could see a hand in one of the windows on the left side. That is the downward facing view through the camera of the mat. And on the right side of it is just the screen of the mat that you could see. On the inside the Unity ID, it's a rollerball tutorial which is available from Unity's website. It's just half the way through, just for the demo purpose. You could view that how it's built on the Unity's website. I'm going to run it without any modification, and then I will let you know how to Sproutify an app inside Unity for Sprout. Let's just run it. So as you could see, might be able to see there's a ball that I'm controlling through my keyboard, arrow input, arrow buttons, and there are two obstacles just on the screen. I'm going to go back, and now I'll introduce you how to use the Unity plugin. We'll import the Unity plugin package into our game. This is a single file that you could import. It's decompressing and it will take some time to get all the files imported inside the Unity IDE. I click import. And it will take some time. Thanks for your patience, guys. It's done, but it's taking some time. I'll just give it a few seconds.
While we are waiting on that, I'll send out one more poll.
As you could see, under the project folder, there is a Sprout named folder. That's all the content of the plugin. And now, since the plugin has finished importing into the Unity, on the menu items and the menu bar, you could see a Sprout menu, and it gives you capture mat, show mat preview window, and SDK version info. Show mat would just give you the preview of your mat window, and the capture would let you capture objects from the IDE. So what I'm going to do is now expand the Sprout. We have already made two prefabs. One is the cameras, which gives access to the two cameras, main camera and the mat camera. Both cameras are used to set your main screen view and the mat screen view, as well as a Sprout Manager prefab, which gives you access to Sprout functionalities inside your app. I'm going to go and delete the main camera coming from the game. Now, as if you could see inside the game view, my game view has been split into two screens, the main screen and the smaller mat screen rectangle below that one. I'm going to go and set the main view camera and the mat camera to the views I would like to set them to. So I've set my main camera to front view, and I'm going to set my mat camera to top down view. For that, I would go and set the projection, changed it from orthographic to perspective. And now I can see the top down, but it's not visible clearly. So I'm going to change that as well. I can see the view in my game view, how it looks like. Now I can see the whole game area from the top down view on my mat. Now I'm going to run this just to see how it looks. So I'm not able to get that. So I'm sharing my Sprout both screens through the third monitor, so I would need to reset it. Thanks for waiting, guys. Let me try running it again. What I would like to see is on the bottom two rectangles that the mat area should display on there. Yep, again. Yep. Maybe let me do it. Can you Okay. Now, as you could see, it's visible on the mat as well. Let me just run it once again to make sure. Sorry, guys. It's just the third monitor which is taking some time. I really appreciate your patience and bearing with me. Let me just So I'm just gonna reset. Right. So finally, sorry guys for such a delay. Now you should be able to see two screens, two views of the same game area. One is the mat view, which is the top-down, visible through the top-down camera and the mat screen area, and as well as the front view and in the maximized main screen. I'm going to proceed with the rest of the demo now. So what we need to do is, what I'm going to demo today is, like, first was the dual screen, which I just showed you. The next thing I'm going to show you is how to capture some object and apply that as a texture to some game object. So capture a real life object and then use its texture onto the player of my game. So for that, I need one button to perform the capture. I'm going to create a UI button. Let's call that button capture. Save that. And reset it. I want this capture button to be displayed on my mat, so that's why I would change the canvas render mode to camera, and then I will change my camera to my mat camera. Now I can see it's hiding behind the game area, so I just need to adjust it so that I could see it clearly. And I'm going to change a little bit so that it's big enough. And run it to see how it looks. Yes, I can see the capture. It's not that beautiful though, but I can see it. So next I'm going to write a script that will perform the capture and apply the texture. So for that, I'm going to create an empty game object and rename that to capture script holder. I will add a script. I'll open that script. It's going to take some time to open that in Visual Studio. It's just loading the Visual Studio. It's taking some time. So it has finally opened that. So this is the default script that comes when you create a script. So I have already a skeleton of my script. So this has very Unity specific functions, like I'm gonna copy paste them over here, like awake, one capture object which I'm gonna use for capturing, and on enable, on disable. So awake will be called when the script is loaded. It will be called only at that time. OnEnable will be called when my object is accessed. And and you can see at the top it's using Sprout. But this is available because I use the Sprout prefab in my game. So I'm gonna create Sprout manager variable Sprout. And inside my wake function, where the script is finished loading, I'm gonna initialize my Sprout variable to GameObject.find Sprout manager dot get component Sprout manager. And in case if there's some error, and it fails to initialize that variable, give me a log message. Followed by awake, I have a capture object function. This method is going to perform the capture. This capture movement is coming from the plugin. It takes two inputs. The first, these are all both Boolean variables. The first one is false, and second one is set to true. The first input is like either I want to capture the whole image of whole mat, whatever is on the mat, and the second input is whether I want to get the children images, the children segmented, separated objects present on the mat. So I don't want the whole mat image, I just want the children images. And for this demo purpose, I'm just going to use one object, which I will show you very soon. Inside OnEnable, when this object is enabled and I could access it, I would like, so how capture functionality one works is when it's finished capturing all the objects, it will generate an event on capture object ready. And at that event, I will subscribe it a method call, and that method will be called. And whatever I want to do with my captured objects, I will do inside that method. It will get input variable of type capture listing, which I will show you. On capture, there are a bunch of events. Among those events I'm going to use on capture objects ready. On capture complete will be triggered when the capture is complete, and on capture object ready, which you are seeing on my screen right now, will be triggered when captured objects ready. I will create this function soon. Inside my on disable function, I'm going to create unsubscribe to this function call, and I'm going to create this function as well, void capture listing. Capture listing will, an object of type capture listing will provide me all the captured objects. For this demo, as I said, I'm going to be using just one single object. And so what I want to do is the player, as you saw in my game area, I will capture the object and apply the texture of that object onto my player area. For that, what I would need to do is I would need to create a game object player, and inside my function, I will okay, I think get component for that player, renderer type. Material, and for that material, set main texture, set it to listing dot texture. Since there will be just one object, that object's texture will be applied to player. But before I could use this script, what I need to do is I have to assign that player variable, public variable that I created here. I have to make it public so that I could see that in my Unity ID to the player area of my game. So as you could see inside my Unity ID, there's a player variable visible. I'm going to go to my game area and drag this player and assign my variable this player. Now the final thing that I need to do is assign that start capture to my button. For that, I go to the inspector under the button and add an event to onClick event. Assign it a capture script holder, and from capture script, this is a capture object function that I created here, as you could see, and that will perform the capture. So I'm all set to run this demo, and I'm going to play it. I have this apple that I'm going to put on my mat and do the capture. It sometimes takes some. Okay, here's it. It's doing countdown. You could see the flashlight on the mat area. The ball is white. It's gonna soon have the texture of my apple. It takes some time. Um, it just took some extra time, so there's some problem in Unity editor. Let me just relaunch it again. And I'm gonna try once again. There was a problem with the sharing, so okay. There's some technical issue with the machine here. I have, unfortunately. Pass on to you. What's wrong? Guys, there have been some issue, unfortunately, with the machine, so it's rebooting. So what I wanted to show you was like capture the object and apply the texture, the outer skin of the apple to the ball. So I'm gonna because we're running short on time, I'm gonna pass on to Ruben, who's gonna give you demo on RealSense.
Right, guys. Okay. All right, guys. So for the Unity, we will just be providing you with more information, and we're having some issues when we're connecting the Sprout to a third screen that we're using to share the information with you. But we'll make sure that those issues don't happen when you are actually testing it. And now what I will be talking about is the RealSense. And for this, you're here. Do you hear me?
Yeah.
There. Okay. Justin, is the sound correct? Hello?
I'm sorry, what's that?
Is the sound all right?
Yeah, sounds good.
Okay, okay. Sorry, guys. Okay, so for the RealSense, the Sprout comes with a RealSense camera, and so far we have used that camera for using segmentation of objects. That means that when you're scanning something, it is able to separate. Yeah, and if you put several objects on the mat, it is able to separate them because it's able to detect the edges. That's where we use the depth information of the RealSense camera. The problem that we have had is that that camera can be only used for one application at a time, and we wanted to make sure that whatever application was running can we can bring back the Sprout experience that we're correcting, and that's where we have been locking the camera. Now, with a new release of the Depth Camera Manager from Intel, it will actually allow several applications to run the RealSense at the same time. It will just orchestrate between the applications. And that's what we're going to be talking about, and I'll be letting you know when you can actually get a hold of the RealSense camera. So the message that we have for you is, first, for you, the developers, we will be providing, we will be unlocking the RealSense camera in the next few weeks via an SDK update. So we will make a new version of the SDK that when you run it, it will unlock the camera. Now, for the consumers, a couple weeks later, after we release the SDK for you, we will deliver a Sprout platform update that will unlock the camera for all the consumers. Now, let's talk a little bit about the RealSense camera on Sprout. So the camera that you will find there is the F200. It's a front-facing camera designed to be front-facing, and it's just the same one that you will be able to find in the Intel developer kit. It will give you the a stream of infrared and VGA at 60 frames per second, and RGB at 1080p as well. And it's designed to work in a range of 0.2 to 1.2 meter. And it has a big asterisk when you look at the specifications, because it depends a lot on the configuration of the camera. But now, this is not the only camera that is on the Sprout. As you can see on the picture, we have the RealSense camera that is there with the 3 different components, but we also have a high-resolution camera that is just a little bit on top of it. And I will show you the differences between the RealSense camera and the downward-facing camera, and when you could use one or the other one. Now, one thing to be mindful on Sprout is that this camera is looking downward. That means that there is some usages that come with the RealSense SDK that are not optimal for it, but there are some other ones that in some cases will work fine, in other ones you need to be careful. For instance, you can definitely use the hand skeletal tracking. It will provide you that information, and in terms of the hand gestures, some of them will work, some of them may not work in the way that is designed, because this one is looking down. It does perform the 3D segmentation, so you can get the depth information of the volumes of the elements that you put on top of the mat. Like if you put your hand, it will be able to actually detect that you have your hand, as you can see in the lower part of the camera, but I'll show you a sample. And but if you are going to use on face recognition APIs, well, you're going to need to put your face down there in a very weird position. So those are not optimal to work with Sprout, but getting the raw data works. Okay, so this is how the camera will look down. So one thing that you'll notice is kind of inverted, and it's a very wide angle. It's a 69 panoramic view of the objects that are on the map. Now, for using the RealSense camera, what you will need to do is, well, after we roll out the new version of the Sprout SDK that will include the new Depth Camera Manager, you want to go to the Intel website and download the RealSense SDK. With that SDK comes with APIs and documentation that you can use to run your samples. And you can, some of the languages will require you to run a runtime. Like if you want to do some web development, you need to run this their web runtime. And the cool thing is that you can use the RealSense SDK along with the Sprout SDK. So you can use the best of the two technologies to make very interesting applications. And you can also use the Unity SDK along with the RealSense SDK, the Unity plugin along with the RealSense SDK. Now, what I will do is I'll give you a demo of what you will find on the RealSense SDK once the camera has been unlocked. So when you download it from the Intel website, you will see this folder, and one of the tools that is cool and interesting to see is this capture viewer. So with the capture viewer, what I will do is just open the stream of the different cameras. You can see here the Intel RealSense camera and the other cameras that the machine has, and I can actually enable the different streams that they have. So I'm gonna open a VGA stream of the color. This is from the RGB camera, and infrared as well. And this is the depth stream as well. That is a computation, and then I can start them all at once with this application. So you see here, let me just organize this on the screen. These are the 3 cameras from the RealSense camera. The first one is you see the RGB, and then the next one is all these infrared dots that is kind of putting down. And the third one is actually the computation, is the volume information. You can see how it is able to segment my hands from the background in this case and separate them. And now the difference with the Sprout camera that you can actually see on the lower part. Well, the first thing that you see on the Sprout RGB camera that is on the bottom right is that this one is contained only on the 4 corners of the Sprout. So that's called a keystone. While the RealSense camera has a wider angle, is able to see more space, but the image is upside down. There is ways to invert and to mirror that programmatically, so you get the flow in the correct way. Another tool, I'm gonna stop all these cameras. Well, this is not a tool. Another interesting thing that you will find on the RealSense SDK is the samples. So if you go to this framework, you will find samples in the different programming languages. And I'm going to run a couple of them that are on C#. So the first one is this hands viewer. And it will open in Visual Studio. I haven't done anything with it, I only open it and run it. And so when the solution is loaded, I will just run it, and it'll take a little bit. There you go. And then I'm going to start it. Okay, and then if I click on start, you will see the flow of the camera running. Just give it a second. There you go. So as you can see there, if I put my hands, it is able to detect actually the hands, and each finger has its own color, and it's able to separate my hands from any other thing that I have on the background. So this is the model, the hands model of the RealSense that you can use. The hands is something, well, very natural to use with Sprout, and I can actually detect some of the gestures. For instance, this full pinch. If I do this, let me just get. You see that it does this full pinch gesture. Now the funny thing is that it says that it's left hand. I'm using my right hand, and this is a result of the configuration as a downward camera. And you will see that there is several things like that kind of work in a kind of weird way. But you just need to be mindful. You could probably use them, but you just need to be mindful of the way that they have been designed for. Now I want to show you another sample that uses the 3 dimensions of the camera. I'm going to run this touchless controller viewer. It's actually a pretty cool sample because you can manipulate the 3 axes of it. Now on the Sprout, the axes are a little bit different because of the configuration of the camera, but they are all accessible. So each point that you detect with the camera has the XYZ coordinates. It's just that you need to probably the coordinates don't match to the ones if you were using it as a front-facing device. Now I'm gonna run it. This one loaded much faster. Okay, and what you will see on the screen is when I put my hand here, I'm gonna make it full screen here. When I put my hand appears on the screen, and if I grip, it's gonna grip there. So if I move it to the sides, like gripping, you will see in the button how these letters will move. If I put it upside and down, you will see the numbers on your left side that they go up and down. And if I push it up closer to you, to the camera, you see how it zooms in. And if I bring it down, it zooms out. So it's a pretty cool sample of how you can actually use all this space to do something, to do some pretty cool applications. And well, and another thing that is interesting in this framework is that you can also run JavaScript apps directly on the browser. So it has this Hans viewer that runs here directly on the browser. And for this one, you actually use this web runtime SDK, web runtime, sorry. And I'll show you in a second. Here, it detects the platform. I can start it, and this is just running on the browser, which is pretty amazing. And now I put my hand, and then you can see two hands with all the joints. Okay, some food for thought here on some couple ideas of the cool things you could do in RealSense. You could do a lot of very interesting enterprise ideas, or just some funny, interesting ideas. You could do Darth Vader Strangler if you wanted, or orchestra director. A bunch of interesting things. In fact, one of these things that we play around, we created a theremin. I don't know if you have seen what a theremin is, but it's an instrument that uses the 3 dimensions. If you get your hand close to an antenna, it will produce different sounds. So here's the same. It's just that according to my place on the screen, it will give a different frequency. This is a sci-fi instrument. I'm going to stop it. And now, and the cool thing is that I'm using the two screens of the Sprout, one for manipulating, the other one for visualizing the waves. And yeah, that was pretty much it on what we have for the RealSense. And again, we'll be making these tools available to you in the upcoming weeks. And what I will do now is I will go to the questions that you guys have. For that, let me just see what questions are on the panel. And okay, so I was reading this one. It's the first one from Joseph Anderson. In general, I think the question is that if there is any way to take an image, for instance, from an X-ray on our series of MRIs, and scan it into the computer and analyze the structure or injuries. So the point is that with the Sprout cameras, you can scan any kind of object. So if this is X-ray, and then the rest of the computation will need to be done by your program, right? Unless if you use the RealSense, for instance, you can actually detect things that it joins. But if you want to actually detect an injury, there will be some patterns that are very specific to your image, and then you will probably need to do that computation. Or if there is any library that will be done, you can use that. And for that, we provide ways to use C++, C#, anything that is a lot of technologies that you can use for developing on Sprout. And let me see. Okay, so this is that once you download and get accustomed to the SDK, we will can you alert of some hackathons, so I can try some of the questions I asked about.
Yeah,
and we will definitely, okay.
That'll be me, Ruben. I'll have everyone here in our subscriber list so that as we have Sprout events, everyone will get an email.
Okay. Maybe, and then there is again a question from Joseph. We're happy to discuss with you, give you some ideas of the things that can be done. For this, I guess that most of it will require some custom development. Well, we're working on some of the tools so you can actually use them easily. So maybe you can definitely contact us. I'll share my email address with you guys as well, actually. So I'll put it just here.
We had another question by Jessica Joseph asking, with the camera, is the image reversed for left and right like it would be on a TV camera?
It is for the RealSense, but for the Sprout camera, the RGB camera, it is not. So for that one, it's actually as you will see it with your own eyes. That's the way that it's presented. So when you are getting the list of cameras from the device, you can select once it's unlocked to use the RealSense, and probably the RealSense may have several streams, or the Sprout downward-facing camera. So it depends on which camera you select. Now the downward-facing camera, it only looks what is inside on the four corners of the mat. The RealSense is able to see a wider view of the elements.
We have another question by Christopher Phillip, who was at the, let's see, what did it say? In the San Francisco hackathon. So I'm going to just open his mic up to you, Ruben.
Okay, but okay.
Joshka, can you hear me? Okay, might not have a mic in. But he wanted to get your opinion on the difference of the SDK strengths versus capturing of user handmade 3D models for use in animation.
Can you say that again, Justin?
I wanted you to briefly summarize the most significant relative strengths of the RealSense camera SDK versus the Sprout SDK.
Okay, so the RealSense SDK has a set of libraries that take advantage of some of the depth information, while what we can do with Sprout is actually get a 3D model of an object that you put on top of the mat. So actually the RealSense has also a 3D scanning API. I have been playing with it. I think that for this type of RealSense might not be they have another camera that is a longer range that will be able to give you a better 3D scan. And in terms of the 3D scanning with this one, you will find some APIs. Maybe you are able to do something on it. It's a very different experience to scanning something with Sprout. Now, scanning a hand is a little bit different because what we do with the 3D scan is you put an object, you start rotating it, and then it takes different screenshots of it, puts them all together, and then creates a 3D model. And for that, you need the object to be very still and always the same. Then your hand is a little bit hard to keep it always in the exact same position. So for that, maybe you can actually use the RealSense because that will not have that very specific limitation. And I hope that was clear. Let me just check if there is any comment, or I don't know if you heard the question, Daniel. On the and give me just a second because I have one of our computer vision folks here. I'm just gonna repeat the question to him and see if he has any additional comment.
And Christopher, who asked the question, did say thank you. Got it.
Okay, so he said that he got it. Okay, well, Okay, that's and then that's on 3D, but the RealSense has a bunch of other APIs as well that you can get the depth information that we don't, like very specific points on top of the screen, X, Y, Z on real time. We don't have such API, but through the RealSense you can actually do it. Let me see if there is any.
It looks like there was a question from Davey Baker. I can't tell if it's a question. It says 2 objects from 2 color object for dual extrusion printer.
It says, will the new SDK allow for 2 objects from 2 color object?
Oh, there we go.
Okay. Let me see with David. It says, will the new SDK allow for 2 objects from 2 colored object, 2 3D files? Okay, so this is the thing. So if you want to get a 3D file, you can use this Sprout to do 3D scanning. That will give you one 3D file of an object that is very still. You put it on top of the mat. It takes some time to do the scanning, around 15 minutes to do the scanning while you move it around. It's not a real-time scanning, but it gives you a really good 3D capture of that object, and that is for one object. If you want 2 objects, you put it 2 times. Now, yeah, it's 15 to 20. Yeah. Sorry, it was just telling me here to make sure that you the process is 15-20 minutes. It depends on the object, how big the object is. Now for the RealSense, it's a little bit different. You could probably use the 3D scanning functionality. It's something on I don't think there is a library right now that allows you to make it very high level. You'll probably need to do a bit of work on that. If you're just taking the raw stream and detect that there is 2 objects real time, that you can do it with the RealSense. Just kind of detecting there is 2 separate objects. In fact, there is one of the modes that the RealSense have is called the blob. It's for detecting objects. So the hands model is for detecting hands. The blob model is for detecting objects itself. And okay, so David said, thank you. I hope that answered the question. I think those are all the questions that we have. So what we're gonna do is that we're recording a webinar, right, Justin, to make it available for.
Yep, I will go ahead and send the recording of the webinar to everyone who registered and attended, and I will also post it for access online.
Yeah, and we will provide some documentation on how to run the Unity as well. We had some technical issues, but it should be in pretty good shape. It's just connecting it to a third screen is where we have some issues to switch. Yeah, we appreciate a lot for coming to the webinar, taking your time in the evening, and hope you find this exciting, and we'll another time. Thank you.
Thanks, Dan. Hi, guys. My name is Sohaib Ajmal, and I'm a developer support engineer for Sprout team at HP. And I'm today going to introduce a Unity plugin for Sprout to you. So let's start. So Sprout plugin for Unity is a package that you could import as a plugin inside Unity IDE. It provides 2 specific capabilities for Sprout. One is the utilization of Sprout's dual screen capabilities, and the second is the customized capture specific for Unity IDE that I will show you in a demo in a while. The plugin supports C# for Sprout development, and the minimum requirement for development is Sprout Platform 1.2 onward and Unity 5.0 onward. You can also develop using non-Sprout system like your laptop and another screen with that, as you would develop for any other non-Sprout system. So let's start the demo. Before we begin, let me just show you what you are seeing on the screen right now. The maximized screen where you see the Unity, it's the main screen of the Sprout. On the bottom of this screen are two views of the same screen, that is the touch mat of the Sprout. On the left side is the top-down camera where you can see my hand, and on the right side is just the touch mat screen itself. So when I will make it this app, which I'm running right now, for the Sprout, you will see it on the Sprout mat as well. So what you're seeing in Unity ID is a rollerball tutorial from Unity website, which is the first beginner tutorial from the website. And it's a half the way through because this is just for the demo purpose. And I'm going to make it this a small game for the Sprout, change it, Sproutify it. So let's begin. So this is just a ball that you could use your fingers to control and roll around in the game area. Now we are going to make Sproutify this game. I will import the plugin file. It will take some time to load this. Thanks for your patience, guys. So it has finished importing the plugin. We'll wait for a while until we see the Sprout menu in the menu items. So we see the Sprout, the capture mat, show mat preview window, which gives you the preview of the mat window. So now we can begin to make this app for Sprout. Let's delete the main camera. The Sprout plugin comes with two prefabs. One is the camera's prefab, which gives you access to the main and the mat camera. I will drop down on my scene, and the Sprout manager, which gives you access to the Sprout functionality. You can go and you can set the main camera to the main view, what you would like to see on the main screen, and the mat camera to what you would like to see on the mat screen. I would like to have a front view for my game area, so I'm gonna set it accordingly. Go to the mat camera and change the projection from orthographic to perspective, and adjust the view to have a top-down view on my mat. Now I will run and see how it looks. I can see the split screen view for the two screens, main and the mat, but I need to get the view on my mat. So there's a workaround that I would do. I'll change the layout to 2x3 and run it again. Now, as you can see on the screens, on the mat, I'm seeing the top-down view of the game, and on the main screen, I'm seeing the front view of the game. Now what I'm going to show you is the capture functionality. I'm going to capture an object and apply that as a texture onto the ball. The capture is customized for Unity. For that, I would need a button that will perform the capture. I'll change the text to capture. The canvas that holds my button, I'm going to change it to screen space camera and set the camera to mat camera so that I could view the button on the mat. I'll reset it. I could see that it's now hiding behind my game area, so I will adjust the view. I will also like to adjust the size so it's let's see how it looks. It's still hiding. It almost looks good now. Next, I would need to create a script that will perform the capture. I will create an empty game object and rename it to capture script holder. Add this script and open it. It's going to open it in a Visual Studio and it will take some time. Thanks for your patience, guys, again. It's just loading it in the Visual Studio and taking some time. Sorry for the delay, guys. It took some time, but now I can see the script in the Visual Studio. Let me increase the font size. So I have this the basic functions of the Square Unity script already created so that it will save us some time. I will copy paste them here and start building my script on top of it. As you see on top of the script, I have already included the Sprout, which I'm getting because accessing because of the Sprout manager that I dragged onto my scene. Then we have a wake function that will become enabled when the script is loaded, and onEnable will be called when the object for the script is enabled in the game, and disable will be called when this object get disabled. So I'm going to create my script. Let's create a variable of the type Sprout Manager that will give access to the Sprout features such as the capture. I will initialize it in awake. GameObject.find of type Sprout Manager. I'll copy paste. Get component for that game object. And in case if it's not able to find it, give a message saying that it's unable to find the Sprout Manager. Next, I'm going to create a function that will capture the object. Inside this, I would do the capture using my Sprout variable. It takes two input. The first is would I like to have the image of whole mat, and the which I'm going to set false because I don't need image of my whole mat. And second, I'm going to set to true, which is for like, do I need the children objects present on the mat, each object individually? Yes, but for this time I'm going to use only one object. Then in onEnable, so what happens is when I would perform the capture object, it does the capture of my mat area, and once it's done capturing all the objects, it will trigger the event called onCaptureObjectReady. And at that point, inside my onEnable, I would like to subscribe a function to that event so that when that event is triggered, onCaptureObjectReady, I should call objects captured function and subscribe to this event. And inside that function, I will show you in a while that I'm going to apply the texture to my game player of the game. I will copy paste the same code here and unsubscribe to the same function. I'm going to create this function. This function gets the capture listings, all the objects captured from the mat, and pass on inside this function. Before I proceed, I need to create a player variable that I will assign to my player that I showed you in the game. And in order to access it from the Unity ID, I need to make it public. And here I would apply the texture of my captured object onto my player. I get the texture of my captured object listing dot texture and apply that to my player game object, which I've created here, and set it to public. Now go back to IDE and Control S so that I could see my game variable player here, my script variable. As you see that on the screen, that player has appeared here in the capture script. I will go to my game area and drag and drop the player on here. So this player is now assigned to the player that I created inside the script. The last thing that I need to do is go inside the button that I created, add an event, on click, assign it the capture script holder object, and capture object function I will assign that to, so that when I will click onto this button, the capture object will be called. Now let's run the game. Before that, let's check everything is fine here and I'm getting no error. It looks good. Let's run the game. So now I'm going to place this apple onto my scene. As you could see in the top-down view of my mat, I placed an apple and I will do the capture. Sometimes it takes more than one click. For the capture to start. Let me just go and make my button a little bit bigger in the size. Sometimes that helps. And set my camera view so that it's moved a little onto the left side, and run it again. So it is doing the capture. Probably the button wasn't of the sufficient size. The flashes of the capture. It's doing the scanning and it's taking some time. So unfortunately, Unity editor has stopped. So I'll close the program and just quickly run it again. Let's once again try the game. The button has gone out of the view. I'm just quickly going to adjust the size and set the view again. Sorry about that, guys. It's somehow the unit is changing my view. So now I could see the capture button. I'll just move my game area a little bit further from on the math view. So it's again not showing on the mat area, so I'm going to change the layout 2x3 and run it again. Once again, I'm going to try the capture. Thanks for your patience, guys. As you could see, the apple that I put on my mat has been captured and applied as a texture to the ball. So through using the capture functionality of my Sprout to Unity ID plugin, I have captured and applied that as a texture to the game. So that's all about the Unity demo. Thank you very much for your time. Now I'm going to pass it on to Ruben